Sathyabama Institute of Science and Technology.
Hi all, I'm Gowri Manohari, Assistant Professor, Department of Computer Science Engineering in Sathyabama Institute of Science and Technology. Today, we are going to see a topic in deep learning called GAN. So, first we are going to see the agenda of today's session. What is GAN? That is, GAN expansion is Generative Adversarial Networks. The main two components of GAN is one is generator and another one is discriminator. Then we are going to see how the GAN works. Then types of GAN. Finally, we are going to see the applications. What is GAN? GAN means Generative Adversarial Networks. It is a neural network and it comes under unsupervised machine learning algorithms. Now, it was developed in 2014 by Ian J. Goodfellow. Past 10 years, more than 10 years, it was been a trending technology in deep learning. There are two main components in GAN. One is generator and one is discriminator, used to analyze, capture in various data from the particular database. Here, in this database, the generator and discriminator, the two main components of GAN. Here, the generator is used to create the fake objects from the taking the samples from the database and is used to create the fake images. And the work of the discriminator is to identify the images whether it is real or fake. So, first in GAN, we are going to train both the models, that is the generator and the discriminator. First, we are going to train the generator. So, here we are taking the random input and this is the real images, and here generator creates a duplicate image as like a real images and it will be given to the discriminator. So, the work of the discriminator is to find out the data whether it is real or fake. So, we are going to train both the components, that is the generator as well as the discriminator. So, here after the discriminator, whether it's identify the data whether it is real or fake. Whether it identifies the data, it will give to the generator. If it is not identified, it will be a discriminator loss. So here, if it is identified the data is fake and it is given again to the generator to give the real one, this process is known as backpropagation. Backpropagation already many concepts are being explained detailedly in deep learning concept in neural network, that is perceptron, how we will backpropagate. Backpropagation is nothing but we are giving the inputs and weights. Always in neural networks we will be giving input as well as weights. When it is not accepted by the model, we will backpropagate the data to regenerate the result to give the accuracy. So here, while backpropagating, the input always should be constant and always we should change only the weights. This concept is called backpropagation, and here we use a concept called backpropagation. Now, discriminator. So here the discriminator is a classifier that identifies the real data from the fake data created by the generator. So already I have discussed like discriminator. What is the job of the discriminator? To find whether the given data is real or fake. Here we use a classifier. So what is a classifier? We can use a binary classification. Binary classification means it will be classified from 0 to 1s. Here in this model we use a binary classification method and we use some activation functions. Activation functions is rather than step function, sign function and sigmoid. Here we use a sigmoid function where it will be varied either 0 or 1. Now, discriminator training. How we trained a generator to create the fake data as real data. So, any example we can take. We can take human faces or any 100 rupees notes, any images like any image, sample image we can take as an example as a real data, and we have to create a duplicate one. This is the process done by the generator. So, here I am going to train the discriminator to find the exact data, that is whether the generator has given the data which is real or fake. So here again I am going to separately, here both generator and discriminator should be trained in this neural network model. So now the training of the discriminator, the same process. Here I am taking the real images, samples, discriminator. So here I am training the discriminator to identify any real data is sent by the generator. So here, if the discriminator fails to identify the fake data, then it will be a discriminator loss. So again it will be given as a backpropagation. Again the data will be resent to the database. How the GAN works? So GAN consists of two networks, that is, one is generator, and here we will be consider the generator as G of X and the discriminator as D of X. Here the random noise is nothing but the random values, the data which we are going to take, and is given to the generator. Here the generator will be, here this is the real data, that is I am taking as an example of any picture. Here I am taking a Taj Mahal, a picture of Taj Mahal. So this is the real data given. So the generator take any images, that is it is taking this image and it is recreating as a new one. But definitely there will be a difference in the new one, that is a real images and the fake images. So here this generator has been taken the real data and it is created its duplicate one and it will be sent to the discriminator. Here already we trained the generator how to create the duplicate image. The training has been done separately. Now again we done with the discriminator training also how to identify the fake images given from the generator. So this discriminator should identify whether this generator send image is real or fake. It should be clarified with the real data and should be clarified with the data given from the generator. So it will identify either real or fake. Only one output will be given, either 0 or 1. So here I am assuming the generator G of X, that is the fake data, as G of X is equal to 0, and the discriminator D of X, that is a real one, as 1. Then again I am taking the generator, the distribution of data and strain increase the probability of the discrimination network to make mistakes. So here later we will be seeing with the mathematical calculation how we are going to solve this in the neural network model by using the mathematical calculation. Both generator, how we train, again we are going to deal with the discriminator to identify the images in the binary classification method, that is 0 and 1. Here the mathematical formula is given to solve this neural network model, that is, this is the expression given, and here we are identifying D as discriminator, G as generator, P data of X, that is nothing but the probability of real data distribution, and X is the sample data which we are taken from the database. Then D of X is the network of discriminator and G of X is the network of the generator. So here P of Z equal to generator distribution. Then Z equal to P of Z sample, that is the output which we are going to create, whether the given from the generator it is a real or a fake, and the discriminator whether it is finds the data which is given by the generator is real or fake. Then the steps for training the GAN. So what is the steps for training the GAN? The both generator and discriminator should be trained properly in this neural network model. The first we have to identify the problem. Then we have to choose the architecture of GAN. After collecting the data, we should choose an architecture to perform this GAN. Then training the discriminator as like a to find out the data is real or fake. Then we have to train the generator to produce the fake data. So both the generator and discriminator should be trained in this network model. Then train discriminator on fake data. So if we are going to identify something, it is a fake or real, we should train the discriminator by giving the fake data also, how the fake data will look like. For example, if I am giving a 100 rupees note, a real note, and if I am giving the 100 rupees fake note, it should be trained on both the data, how the real 100 rupees note should be, how the duplicate 100 rupees note should be. So both the things should be clear with the training model, that is the discriminator should be both trained in both the aspects. train generator with the output of the discriminator. So here the generator, if the discriminator identifies, okay, this is the real one, this is the fake one. If it is identified the fake one, the generator should take the feedback. Okay, this has been identified by the discriminator and it has been identified as a fake one, and that feedback from the discriminator, again the generator should be trained what are the negative has been done, how it has been found, and again it should be trained to modify that duplicate one as a real one. But it is not a real, but again it should be trained with the duplicate data by making it as a real one. Types of GAN. So there are some types of GAN. First one is vanilla GAN. Second one is deep convolutional GAN. It is also called as DC GAN, and conditional GAN is called as C GAN, and super resolution GAN, that is called as SR GAN. So first we are going to see what is a vanilla GAN. So this is a simple type of GAN where the generator and discriminator are simple multi-layer perceptrons. Already we see what is a perceptron. In neural network, what is a perceptron? It will be having a network hidden layers. It will have some number of layers, and we will be giving as an input with the weights. It will be multiplying both the inputs and weight. It will be given to the addition formula we will be given, and it will be given to some activation function. Any activation function, probably you will use your sigmoid function to clarify with the binary classification, either 0 or 1. So here we use a multi-layer perceptron. Multi-layer means we will have more number of layers. Then deep convolutional GAN. DC GAN comprises of connects and more stable and generate high quality images. So here in DC GAN, deep convolutional, we use a CNN, convolutional neural networks. So here we use a concept called CNN to give high quality images. So in previous example, we saw the clarity of the Taj Mahal example. So if we are taking some data from the database, the clarity of the image, the resolution will be high. So image, how the fake data has been identified by the discriminator, all those things will be enhanced with these quality by using the CNN, that is convolutional neural network. Then conditional GAN. C can use extra label information to generate better results. So here what is the label? Already we have used some label data, that is G of x and D of x. That is G of x which will be identified as generator, and D of x will be represented as discriminator. Here we are using a third one, that is we can label as Z, like we can use as that Z of x also to get the output. So the extra label information is nothing but we are giving additional data, that is we can assume as Z. Then super resolution GAN. So here SR GAN generate a photorealistic high resolution images. So here when given as a low resolution image. So if the data is from the real images, from the database we are taking any images, low resolution images also will be given while we are giving to this particular GAN model. The low resolution data which is given will be converted into high resolution data. So these are the types of GAN. So finally we are in the concluding this model GAN with the applications. So what are the applications where it is being used? So image imprinting with GAN, using GAN in steganography. Steganography is nothing but hiding of data. It's known as steganography. So again we are using in generating synthetic data, image super resolution, image translation, and 3D object generation using GAN. 3D object, converting the 2D model into 3D model. Then image translation, video file, audio file, anything we can be converted by using this GAN model. So in today's session, we saw the elaborately we see about the important topic in deep learning, that is generative adversarial network. Thank you.